1.
We've been looking at how to balance equations, and on the last video I was going over a little trick that works with combustion reactions in particular. These can be particularly difficult to balance as your hydrocarbon gets more complex, but let me share with you what the trick is, and then we're going to do some other practice examples on the worksheet that we use in class today for classwork. All right, so combustion reaction tip for balancing. What I said in class today was to think about the company Hollister and Company. That's the order in which you want to balance each element. So HCO, Hollister and Company. So you do your hydrogens first, carbon second, and your oxygens last. Now this works with combustion reactions. I call it the switch trick. It's just something that I recognized when I was in college, and it happens to work with any combustion reactions. So the switch trick specifically is referring to something you do that pertains to your hydrogens. So what you want to do is you look at your combustion reaction. Notice they start with a hydrocarbon, and for combustion to occur, you got to have oxygen. So that's going to be your other reactant, diatomic oxygen, and it's going to form carbon dioxide and water as your two products. So the switch trick, start with your hydrogen. So what I mean by that is you look at your subscript for the hydrogen. Whatever the subscript is, that is the number you're going to put as a coefficient in front of the compound that has hydrogen in it on the product side, and it will be water in this case. So a 4. So I'm going to put a 4 in front of the water as a coefficient now. And then look at your water's hydrogen subscript, which is a 2, and that is the number that you are going to put in front of the hydrocarbon, which is the compound on this side that has hydrogen. So I'm going to put a 2 in front of the CH4. Now what that does is automatically it balances your hydrogens. Notice 2 times 4 is 8. I have 8 hydrogens on this side. 4 times 2. I have 8 hydrogens on this side. So we have now balanced our hydrogens. So that's the H in Hollister and Company. Now, from here on out, it's pretty much like you would normally balance a chemical reaction. So you're going to look at your carbons next. So let's look at our carbon here. Focus only on the carbons in the methane. So 2 times the 1 carbon gives me, I have 2 carbons on this side. So look over here, and this is the molecule that has carbon in it on the product side. So if you look right now, you only have 1 carbon. A lot of students will mistakenly look to the oxygen and say they have 2 carbons, but remember, the 2 goes with just the oxygen here. The carbon, there's 1 carbon on this side. So I have 2 carbons on this side. So in order to get 2 carbons on this side, I need to put a coefficient of 2 in front of the carbon dioxide. So now I've got my hydrogens balanced and I have my carbons balanced. Save your oxygens for last. Typically they're the element in the combustion reactions that are tricky. And the reason is because on your product side, you've got oxygen showing up in 2 compounds. You got to remember, you're going to have to total up the oxygens on the product side. So it's just simple math, really, but let's total it up. You have 2 times 2. Remember, you're looking at the oxygens. 2 times 2, I have 4 oxygens in the CO2, and 4 times 1, I have 4 oxygens in the water. Now, you add that together. The total oxygens on the product side is 8. I have 8 oxygens on this side. So come back to your reactant side, and we're going to finish up balancing our oxygens. So I have 8 on the product side. In order to make this equal to 8, what times 2 equals 8? That's right, you put a 4 there. So 4 times 2 is 8. Now, one thing you want to remember about a chemical equation and when you balance it is when you're finished, you do have to make sure your coefficients are in the lowest whole number ratio. So I always check that 2, 4, 2, 4. These are all divisible by 2. So what you want to do is come over to the side and you're going to reduce that. If you divide all those by 2, you get a 1 2, 1, 2. So this little trick, the switch trick, works with any combustion reaction. Okay, so now let's take a look at the first 10 on this worksheet. We're just balancing right now is all I'm working on, but I wanted to work through the first 10 of these to give you some extra practice. All right, now in class today, these are not all combustions. So in class today, what I did is I said, okay, there's some little tricks I'm going to show you that I have found work for me and that are good starting places. And so in number 1, what I see here that's a good starting place is this odd number 3. So when you have an odd number, they're typically more difficult to work with. So I always try to make the odd numbers even by multiplying by 2, putting a coefficient of 2. So the first thing I'm going to do is put a 2 coefficient in front of the NH3. Now what that does is it gives me 2 nitrogens. So look over here. Notice you already have 2 nitrogens. And now look at your hydrogens. 2 times 3. I have 6 hydrogens on this side. So in order to make this equal 6 on the reactant side, we can say 3 times 2 is 6. Remember, you're multiplying coefficient to the subscript. So the coefficients needed to balance this equation are 1, 3, 2. And that is in the lowest whole number ratio. Let's look at number 2. I see an odd number here with the oxygen. So this is a place where I would start. That's just a good starting place. There's really no wrong place to start. But this is a good place to start because you want to attack the most complex part of the molecule first. So it's multiply by 2. That's going to give me 2 times 3, 6 oxygens. So come over here. In order to get 6 oxygens, I can say, well, 3 times 2 is 6. That balances my oxygens. And now look at your potassiums. 2 times 1 is 2. So put a 2 in front of the potassium chloride, and that gives you 2 potassiums. 2 times 1 for the chlorine, 2 times 1 for the chlorine. So this is balanced with a 2, 2, 3, and that is in its lowest whole number ratio again. All right, let's move on to number 3. I don't see any odd subscripts here, so I'm just going to start with the subscripts that I do see that are larger than 1. So here's a 2. There's 2 fluorines on this side. So to make this side have 2 fluorines, I'll put a coefficient of 2 in front of the sodium fluoride. So the 2 times 1 gives me 2 fluorines, and I have 1 times 2 gives me 2 fluorines. Now this made me have 2 sodiums on this side, so put a 2 here. That gives you 2 sodiums. This now distributes to the chlorine. It gives me 2 chlorines. Well, I already have 2 chlorines, so understood 1. So now write out your final answer, 2, 1, 2, 1. All right, very good. Pause the video and then try to do the rest of these through number 10, and then restart the video and see what you get for the final answers. Just pause the video and then pick back up. I'm going to go ahead and balance number 4. Number 4 can be balanced with a 2, 1, 2. You should have gotten 2, 1, 2 for number 4. Now on number 5, I do want to show you something that's a really good strategy to use here. And this strategy is helpful when you look at your equation and you see on one side of the reaction a compound that has hydroxide ion in it. Notice here the lead to hydroxide. And on the other side you have a water. So when you see hydroxide on one side and water on the other, this is a little trick that I always do that makes it easier to balance. I mark through the water and I'm rewriting the water formula so that it looks like it has a hydroxide in it. So I'm writing as HOH. I still have 2 hydrogens in it, and I have 1 oxygen, but I'm rewriting this to make it easier for me to balance it, because in this case, the hydrogens will give us trouble if we don't do this. So now, I've got 1 lead here, 1 lead here. Now look, I've got 2 hydroxides. So look at your water and cover up the first H. Look, I have 1 hydroxide here now. So to make that 2, I'll put a 2 coefficient in front of the water, and that's 2 hydroxides. Now, look at your hydrogens. Let's look at the front hydrogen. That gives me 2 hydrogens there. So look over here. Now balance the hydrogen in the HCl. I'll put a 2. That gives me 2 chlorines. And I look over here, I already have 2 chlorines. So it's balanced with a 1, 2, 2, 1. All right, number 6. One thing I would do here is put parentheses around the sulfate there. Notice you have 4 sulfates there and 3 sulfates there. Okay? So one thing I would try, since